We're back. Section 4.3, 4.4. This is number 5. So I just kind of am trying to look at some of our different functions. We've got e to the x, we've got ln of x, we have trig functions, and so on. So here's one with the ln of x in it. And I'm going to state the domain is x greater than 0. Now these are things you should be coming in with from your algebra class or your pre-calculus class. But just in case you don't remember, the x could be any real number, but x, you cannot take a log of a negative number, nor can you take the log of 0. So those are undefined. Logs are always positive, or sorry, not positive, but always defined. Just remember what log looked like that. So that's from 0 to infinity. So our domain is the same as the log. This is not a picture of this function because I've got x times ln of x, but the domain is the same. So I'm going to go first times the derivative of the second plus second times the derivative of the first, and the derivative of the first is 1. That gives me 1 plus ln of x equals 0. Now here, your algebra may be rusty. I'm going to subtract 1. And definition of log, if you're trying to get, so I want x out of that log. What you do is, the definition of log is log base b of a equals c. So you take the base to the power of c, and that gives you a. And in my class, I always kind of call that the round the world, that b to the c equals a, like that. And this is the logarithmic form of that equation, and this is the exponential form of that equation. These are the same equations. It's like two different languages. This is the language of logs, and this is the language of exponents. So to get this out of here, I would ask you in class, what base is this? And I showed you right here, it's base e. You know, natural log has base e, and a lot of times I'll just write the e there as the base, and then I'm going to take that to that power is equal to that, and that comes from the definition of log. So e to the negative 1 is x, and there you've got it. There is, we solve for x. And that's just x is 1 over e, which is about 0.368. This is our critical value. I have my number line, and remember it's just 0 to infinity. This is my f prime number line, and I put that 0.368 right here, and I tried 0.2 and 1, and I got negative and positive. So this means decreasing, and this means increasing, decreasing, increasing. You have a relative minimum. So I'm going to write f is decreasing on 0 to 1 over e, or you could put the 0.368. I thought it looked nice like that. And increasing on this interval from 1 over e to infinity, because this is 1 over e, if you remember, right? 1 over e is the same. And there's a local minimum, remember that goes decreasing to increasing, local minimum at 1 over e comma negative 1 over e. I put that 1 over e in here, and that's what I got, which is just 0.368 comma negative 0.368, and you can just do the decimal. All right, I'll come back for part B.